Hello everyone, myself Dr. Mohini Kuchekar, Assistant Professor at PE Society's Modern College of Pharmacy, Nigdi, Pune. Today I am going to talk on topic resins. In that I am going to cover definition, classification, properties and chemical test for identification of resins. After studying this topic, learners will able to understand what are resins. They could able to describe the occurrence and properties of resins. They could able to classify resins with examples, chemical test for resins and functions of resins. So resins in the most specific use of the term is hydrocarbon secretion of many plants, particularly coniferous trees. It is distinct from other liquid compounds found inside the plants or exudated by plants, such as sap, latex, or mucilage. So, scientific definition of resin is resins are amorphous solid or semi-solid substances that are invariably water insoluble but mostly soluble in alcohol or other organic solvents. Then let's discuss about its occurrence. So, in the plants, resins usually occur in different secretory zones or the structural part of the plants. First is resin cell, example ginger. Second, that is schizogenous ducts, example pine wood. Third example, that is it is also found in granular hairs such as the example like cannabis. The formation of the resin in the plant is by virtue of its normal physiological functions. However, its yield may be enhanced in certain exceptional instances by inflicting injuries to the living plant, for instance, like pinus. Many resinous products are not formed by the plant itself unless and until the purposeful and methodological injuries in the shape of incisions are made on them and secretion or plant exudates are tapped carefully, such as the examples like balsam of tolu and benzoin. So natural secretion in this kind of plant, it is not occur unless and until you will go for purposeful and methodological injuries to the plant. In other words, these resins are of pathological origin. One school of thought has categorized the term the secretion exclusively obtained from the naturally occurring secretory structure as primary flow, whereas the one collected through man-made incisions on the plant, that is abnormally formed secretory structure, and it is called as secondary flow. If it is naturally, then primary. If it is purposefully done, then the secretions are secondary flow. Let's discuss the properties of resins. We discuss first physical properties and then we'll discuss the chemical properties of the resins. Starting with the physical properties of the resins. Resins are hard, transparent, translucent, brittle material. They are invariably heavier than water, having the specific gravity which is ranging from 0.9 to 1.25. As we have discussed in definition also, The resins are more or less amorphous material but rarely crystallizable in nature also. On being heated at a relatively low temperature, resin first soften and ultimately it will get melt down, thereby forming either an adhesive or a sticky massive fluid without undergoing any sort of decomposition or volatilization. On being heated, if you heat it in closed container, that is in absence of oxygen, they may undergo decomposition and very often gives rise to the empyreumatic product, that is products chiefly comprising of hydrocarbons. Resins are bad conductors of electricity, but when rubbed usually become negatively charged. On being heated in air, that is in presence of oxygen, resins usually burn readily with a smoky flame by virtue of the presence of large number of carbon atoms in their structure. They are practically insoluble in water but frequently soluble in the ethanol, volatile oils, fixed oils, charcoal hydrate, and non-polar organic solvents. For example, here the non-polar solvents like benzene, N-hexane, and petroleum ether. Let's discuss the second part of the properties, that is chemical properties of the resins. Resins in general are enriched with carbon deprivated of nitrogen and contain a few oxygen in their respective molecule. Majority of them undergo slow atmospheric oxidation. Resins are found to be mixture of numerous compounds rather than a single pure chemical entity. Their chemical properties are exclusively based upon the functional groups present in these substances. Consequently, the resins are broadly divided into resin alcohols, resin acids, resin esters, glycosylyl resins, and resins. Resins are inert neutral compounds. It is also believed that the resins are nothing but oxidative product of terpenes. They may also be regarded as the end product of destructive metabolism. The acidic resins are when treated with the alkaline solution, then it yields a soap, or you misstated it as a resin soaps. Let's discuss the next point, that is classification of resins. So resins are basically categorized or classified into four types, that is resins are classified on the basis of their formation, they are classified basis of their chemical nature, then classified based upon the occurrence with other secondary metabolite, and the lastly, that is taxonomical classification. Let's discuss one by one. First classification, that is on the basis of their formation. So the formation, it is again naturally or artificially. When it is naturally, we could state it as a physiological resins, and when we are going to give the injury to the plant, at that time we stated it as a pathological resins. So physiological, it is a natural resin, pathological resins which are obtained after injury. So physiological resins are formed as normal product of metabolism without making injury to plants, while pathological resins formed as a result of wound, injury, or abnormal circumstances. For example, here benzoin, colophony, these are all the examples. Here in the picture also you can see here these resins are natural resins. when resins are formed in the plant, it creates an pressure, and because of that pressure, when it is exceeded, the exceeded pressure, it creates the crack on that particular plant, and through this crack the resin oozes out, and it will look like this. And as we are making an injury, at that time here we have to give incision on the plant, and here you can see the collector is placed here. So as resin is produced in the injurious part of the plant, it can easily collect indirectly into the container, that is pathological resin. Then next classification is classification on the basis of chemical nature. As we have discussed earlier, in chemical properties, it is having categorized into resin acid, resin alcohol, ester resins, resins, and resin phenols. We'll discuss it one by one. First is resin acids. Here, the resins occur along with their acid, example like colophony, copaiba. And next is resin alcohol. They occur as in free state or as ester. Examples are like balsam of Peru with Peru resinotenol. Then ester resin. This is a group contain ester as a chief constituent of the resins. For example, like asafoetida, benzoin, and other examples are also discussed. Then resins. It is a stable, neutral, unaffected by most chemical reagent or by exposure to moisture, produce a hard film. For example, asafoetida. Resin phenols. So name itself suggests that this group contains phenol as a chief constituents. Resinotenols. Next classification on the basis of occurrence with the other secondary metabolite. So in that oleoresin, gum resin, oleogum resin, glycoresin and balsam. We will discuss it one by one. First one, that is oleoresin. So let's start with the oleoresin. So oleoresin, it is a resin and oil in homogeneous mixture are called as a oleoresin. That is combination of oil plus resin. Examples are also discussed over here. Second is gum resin. It is again a resin associated with gum. That is combination of resin plus gum. That is gum resins. For example here Garcinia. Garcinia hanbury is the example. Third is oleogum resins. So it is homogeneous mixture of volatile oil, gum and resin. That is combination of oil, gum and resin. Examples are like milk, gugur. Glycoresins. It is made up of resin and sugar. Glyco means glucose and resin the resin. So it is combination of resin plus sugar. So examples like jalap, apomia is the example. Then balsam are resinous mixture that contain large proportion of cinnamic acid, benzoic acid or both or ester of this acid. The term balsam is often wrongly applied to oleoresins and should be reserved for such substances as balsam of Peru, balsam of Tolu and storax, which contain a high proportion of aromatic balsamic acid. The last classification is on the basis of taxonomical classification. So these resins are grouped together according to their origin. So coniferous resins, examples are listed. Zygophytaceae resins, example is given, and Berberidiaceae resin, that is podophyllum. Then let's discuss the next point, that is chemical test for the identification of resins. First test, when sample containing resin treated with the hydrochloric acid, it will gives a pink color due to the presence of resin. That is, then when sample it is treated containing a resin, when treated with ferric chloride solution, it will gives a greenish blue color due to the presence of resins. The last point, that is role of resin in the plants. Here it is a local irritant and hence acts as a local catharetics. It is used uh, as an anti-cancer in the treatment of human beings. It is used externally as a mild antiseptic in the form of tincture, ointment, and plasters, for examples like turpentine and colophony. These all are the examples of the drug which is the role of the resin in the treatment of humans. By mistake here the plants is written. It is used in the preparation of emulsion, sustained release formulations also in the treatment of humans. Let's summarize what we have discussed. We have discussed what are resins, occurrence in that we have discussed where it is found, and then properties. We have discussed physical and chemical properties of resin. Then next important point we have discussed, that is classification of resin. There it is classified into 4 basic types we have discussed in detail, and chemical test for identification of resins, and function of resin or resin used in the treatment of humans. What are the applications of the resin in the treatment of humans that we have seen. Resins are the excretory product of the plant. So thank you very much for your patience listening. Thank you.